Let's take another example under critical path method. Kindly look at this project. So there are two activities, A and E, commencing from the start. And activity B follows after A and E. Activity C follows after A. Activity D follows after B and C. Activity F follows after E. And these are the durations of the project, each and every activity. So keeping that in mind, let's try to draw the critical path. Let's try to draw the network diagram. So activity A and activity E commences from the start. Activity A and activity E commences from the start. Under the notation, the center box indicates duration of the activity, so 2 and 7 is there. And activity C follows A directly with a duration of 6 days. Activity C follows A directly, duration of 6 days. Activity B follows A and E for a duration of 4 days. Activity B follows A and E for 4 days. Activity F follows E and the duration is 2 days. Activity F follows E for 2 days. And activity D follows B and C for 3 days. Activity D follows B and C for 3 days. And the N signifies by activity D and F. So F, once F is completed and D is completed, an end is defined. So this is the network diagram. And now let's try to again fill in the boxes with the earliest start time and the earliest finish time. So in this method, in this example, we do not use the calendar method. In other words, once the activity ends at the day number 2, we assume that activity C also parallel starts at day number 2. In the previous example, we were using a calendar date method, but here it should have been day number 3. But in most of the examples and even in the PMBOK examination, we follow this unless specifically specified that it is a calendar date method that is being followed. We usually follow the general dating mechanism. So we start from day 0, 2 days for activity A. The earliest finish time will be 2 days. Activity C, we start from the second day, 6 days for it, and the earliest finish time is 8 days. Activity E, starting from 0, it takes 7 days, earliest finish time is 7. And activity F, which is directly after activity E, the earliest start date is 7, 2 days to complete, and the earliest finish time is 9. Now let us look at activity B. In activity B, waits for the output of activity A and activity E. Activity E's earliest finish time is 7 days, and activity A's earliest finish time is 2 days, day number 2. However, activity B is dependent on the output of activity E. In that way, even though activity A finishes on day 2, the earliest start time the activity B can start is after day 7, because activity B is depending on the output of activity E. So therefore, the earliest start time the B can start is day number 7 and activity A, and not at activity A day number 2. Hope you got that. So activity B, the earliest start time is day number 7. The duration is 4 days, and then the earliest finish time is the day number 11. Same thinking pattern has to go for activity D. Activity D is depending on C and B output. Activity C is the earliest finish time is day number 8. Activity B's earliest finish time is day number 11. Since activity D is depending on B also and C, although C finishes on day number 8, the earliest start time the activity D can commence is day number 11. Activity D has 3 days duration, so activity D the earliest finish time will be day number 14. Since there is no activity at the end, in order for the calculation to get easy, we will substitute this end with a zero activity, with a zero day activity milestone. So this is the end. So the earliest finish time is day number 14. Day number 14 is a zero milestone, and the earliest finish time will be day number 14. So on the reverse back calculation, activity D, the latest finish time will be day number 14. 3 days to complete for it. Calculating backwards, the latest start time will be day number 11. Same goes here. Activity C, the latest finish time will be day number 11, because activity D's latest finish time, the latest start time is day number 11. So the latest finish time for activity C is day number 11. The latest finish time for activity B will be day number 11, and duration 6 days. Calculating 11 minus 6 is 5. Calculating 11 minus 4 is 7. And here, straight away from the end, the latest finish time of activity F is 14 days. 2 days for duration. 14 minus 2 is 12. And in this one, in activity E, B and F is depending on the output of E. The latest start time of B is 7 days. The latest start time of F is 12 days. And since B and F is waiting for the output of E, and B's latest start time is 7 days, then the latest finish time of E should be 7 days, because B is waiting for E. And only if this completes by 7th day, the B can start, and the latest start time will be 7. So the latest finish time of E would be day number 7. Same goes here. Latest finish start time of B is day number 7. Latest start time for activity C is day number 5. Since C and B is waiting for A's output, and A's latest finish time should be day number 5 in order to satisfy the latest start time of C, day number 5. So once 5 and 7 is in the box, 2 days for the duration, 5 minus 2 is 3, and 7 for the duration, 7 minus 7 is 0. So as explained earlier, the float is difference between earliest start time and the latest start time, earliest finish time, or the latest finish time. So the float will be 2, float will be 3. Here the float is 0, the float is 0, the float is 0, the float is 5, and here is the dummy. This is a dummy entry. So anyway, the critical path is where the float is 0, the path that the float is 0, So then the critical path will be E, B, D will be the critical path. Hope you got that example correct.